A phase diagram is a graph of pressure versus temperature for a particular substance. There are 3 areas on the phase diagram, and each one of these areas on the diagram corresponds to one of the 3 states of matter, solid or liquid or gas. We're going to begin by identifying what state of matter exists in each one of the 3 areas on the phase diagram. I feel like this is the easiest area on the phase diagram to identify, this area right here, which corresponds to pretty much any pressure as long as you are at relatively low temperatures. And when we're at relatively low temperatures, regardless of the pressure, this is where our substance is going to exist as a solid. There's not enough energy when you're at low temperature. There's not enough energy for the molecules to move fast enough to be either a liquid or a gas. So this is where we find solids. And again, just to help you understand exactly what the phase diagram is showing, this area in the graph represents all of the different pressure temperature combinations where this particular substance would exist as a solid. So area number 1 is solid. Area number 2, this space right here, this is an area where we have kind of moderate to high temperatures. So temperature we're sort of moderate to high, and also moderate to high pressure. In this particular area, this is where we have pressure temperature combinations that correspond to the substance existing as a liquid. We have to have relatively high pressure for the substance to be a liquid because that pressure is necessary to help compress the molecules, push them together so they're in contact with each other. And liquids can exist at a pretty broad variety of temperatures. So area number 2 is where we find our liquids. And then this last area right here, number 3, this is the area that corresponds to a pretty broad range of temperatures and also really a pretty broad range of pressures as well. But one thing that we see that really stands out to us is that when we're at low temperatures and low pressures, what state of matter would exist here? So this is where we have our gases. And again, like I said, the easiest way for me to remember that gases exist in this space is, thinking to myself, what state of matter would exist if I have really low temperature, but also really low pressure? And that makes me kind of think of like outer space or a vacuum or something like that. The low pressure is going to force this to be in the gas phase. So in area number 3, we have a gas. The next 2 questions are asking us about what happens along the lines on the phase diagram. So the phase diagram is going to have 3 lines that divide these 3 areas on the diagram. And these lines represent exact pressure temperature combinations where the substance can coexist as the 2 states of matter on either side of the line. So for example, point E represents one of the pressure temperature combinations where this substance can coexist as both a solid and a gas. Or point number C represents an exact pressure temperature combination where this substance can coexist as both a liquid or a gas. These points along the line represent the boiling points, the temperature at which a substance boils at various pressures. And these points along this line represent melting points or freezing points, the temperatures and pressures where this substance melts or freezes, depending on which way you're going with temperature. And these points represent the points of sublimation, where the substance goes from solid to a gas or from a gas to a solid. This is one of the ways that we can understand, for example, the different boiling point at higher or lower altitudes, differences in melting or freezing points as well. So question number 4 asked us about points, the line between points A and D. Points A and D are along the solid-liquid line. So any temperature and pressure that falls in between points A and D, this represents combinations of temperatures and pressures where we have both a solid and a liquid coexisting. This would be where we are either melting or freezing. Question number 5 asks about points E and D, so that's right here. Points along this segment of the line represent states of matter where the solid and gas are coexisting. So this would be where we are subliming. We have solid and gas. Question number 6 asks us about the triple point. The triple point is the pressure and temperature at which a substance can exist as a solid and a liquid and a gas. Every substance has exactly one pressure and temperature where it can coexist as all three of these different states of matter. And the triple point on this particular diagram is right here, point D. So this is where all the lines intersect. We call this the triple point. And this is the pressure-temperature combination where we have all three of the states of matter happening all at the exact same time, which is really cool. And then the last question here is asking what happens to the substance as it moves from area 3 to area 2. From area 3 to area 2. So regardless of exactly where we are on the temperature axis, when we're moving from area 3 to area 2, we are going from a gas to a liquid. So this would be a condensation. Let me take a look again at the letter. This looks like letter D. So when we go from area 3 to area 2, this is a condensation. If we are going in the opposite direction from 2 to 3, that would be an evaporation or a boiling process. If we go from 1 to 3, that would be sublimation. If we go from 1 to 2, that would be melting. 2 to 1 would be freezing. Did you get the idea?